Guys, so let's go ahead and get going into what we're going to be looking at today. So, guys, if we think about what we talked about so far, one of the big things we've been getting at is variability. Variability, kind of think of it as how consistent are your numbers, how close are they staying to your expected um, amount that you should be getting. So like for instance, like an average. A lot of times, variation is comparing something to your average, which is what we looked at the other day. And what we're going to be getting into today is another type of variation, and it again is getting into the consistency of the data that we have. How consistent is it? And the name of that we're going to be looking into today, at least introducing ourselves a little bit to it today, is called the mean absolute deviation. And just to give a quick definition of that, guys, the mean absolute deviation and this is just kind of straight off the internet, nice, easy, good, straightforward definition for it. It says the mean absolute deviation, or MAD, of a data set is the average distance between each data value and the mean. Mean absolute deviation is a way to describe variation in a data set. So, guys, in other words, what mean absolute deviation is telling you is, on average, how far is each data point from the mean. So maybe on average, the numbers on a list are 2 away from the mean, or maybe they're really far. Maybe they're 10 or 20 away from the mean. Maybe it's way spread out, and they just kind of all are on so far ends of the spectrum that they kind of allow themselves to meet in the middle, because the extremes kind of, for a better term, cancel each other out. So that's an idea that you can think about when you're getting into that. But so what we're going to do here, guys, is we're going to get into how do you find the mean absolute deviation. And we're going to start by kind of introducing ourselves to the idea, and then tomorrow we'll get into actually finding it and applying it to a couple more ideas. So, guys, you should have the notes for today off the Google Classroom page. It should have said 4/6/2020 notes, and then it also below it, there should be a link for 4/6/2020 homework. If you have any trouble accessing those links, please let me know, and we'll work something out. Guys, I'm going to go ahead and just kind of get right to it here. We're going to look at the notes today, and then I'm going to kind of give you an idea, a couple tips when you're looking into the assignment for tonight. But let's just go ahead and get going with it. So, guys, the sheet that I'm looking at is this one right here. And notice, guys, I crossed out a few of the problems at the top. So those few at the top, don't worry about them. Those are just the answer, or the questions to a previous problem that we're not going to get into today. Might come back to it later, but we're not going to worry about it right now. We are going to start down there with this example down here. I think that's, yes, example 2, measuring variability. So, guys, I'm just going to go ahead and just read it real quick. It says, based on looking at the distributions, there are different orderings of variability that seem to make some sense. Okay, so they're getting into the variability. They're talking about, okay, is it staying pretty close to the mean with a little bit of variability, or is it getting a lot of variability by stretching out and getting away from the mean? Okay. Then it says, Sabina is interested in developing a formula that will produce a number that measures the variability in a data distribution. Okay. So she's trying to figure out some kind of method that's going to allow you to consistently figure out how much variability you have. All right. Seems like a useful tool to have if you're going to be trying to analyze some numbers. She would then use the formula to measure the variability in each data set and use these values to order the distributions from the smallest variability to the largest variability. Well, again, that sounds like a really useful tool to have, because instead of having to sit there and eyeball some dot plots like we did yesterday, seeing which ones are close together and which ones are really spread out, she could just come up with a formula where it's just a matter of look at the numbers, and that way if there's numbers that look pretty close together, you don't have to worry about, oh, well, this one just looks a little bit closer, or is maybe this one closer. If you just have a number right in front of you, well, numbers don't lie. If it's a smaller number, it has smaller variability. If it's a bigger number, it has bigger variability. So it sounds like if she could find a method that will allow her to have a number that helps her figure out the order instead of just having to look at the data or look at the plots or whatever she has in front of her, that would be, to me, a lot more accurate of a strategy than just using the eyeball test, right? So let's finish off what it says here. It says she proposes beginning by looking at how far the values in the data set are from the mean of the data set. Okay, she wants to know how far each data point is from the mean of the data set. Well, that seems to be getting, at least approaching, the definition of mean absolute deviation. That's at least a good step to get the average of the distance that each data point is from the mean. It'd be nice to know how far is each data point first. And then once you know that, maybe you could use that information to find the average of the distances, right? So it says on the section that says exercise 4 and 5, which has a dot plot under it, it says the dot plot for the monthly temperatures in city G is shown below. Sorry. So they give you a dot plot. It says use the dot plot and the mean monthly temperature of 63 degrees Fahrenheit to answer the following questions. So they did you a huge favor here, guys. They went ahead and gave you the mean of that dot plot. Now, it is possible to find the mean of a dot plot without just being told the answer. Because, again, all you need to have to find the mean is simply be able to figure out, okay, what are the numbers in my list exactly? And then once I know those numbers, then I could take them and average them out by adding them together and dividing by how many I have. But again, they saved us a little bit of work. That being said, let's just kind of briefly talk about it because I went ahead and already found the mean too. So all I did, guys, was I looked closely first at that dot plot and I figured out, I kind of just did some good estimation there. And I figured out, okay, what number is each of those, or what number do each of those dots represent on that dot plot? And from that, I made a list. And keep in mind that if there is more than one of a number, that I would go ahead and I would write it more than once. Like I have 2 68s. Looks like I have 5 64s on that list, 2 60s. So there's a few of them that show up more than once. And then I just found the mean, guys. So if we look at it, I have my list. I added them all together, as you can see, and got 756. And then I took that 756 and I figured out how many numbers are in my list. And there are 12 if you add them all up. So I divided by 12 and I got a mean of 63. So they are correct saying that the mean in this data set is 63. So what we're going to do is we're going to use that information to look at the back. So if you look at the back, we're going to look at number 4 and number 5. So if you look at number 4 gives you a large table. And it says on that table, fill in the following table for city G's temperature deviations. Okay, they give you an idea of deviation. When I think of deviation, I think of like how far does it stray? How far away is it from an expected value? So deviation kind of works in hand with variability. If you're deviating, like for instance, if you're deviating from the norm, you're doing something that's not a typical response to something, right? So the farther away you're deviating, the farther you are from an expected value. Like for instance, if the mean was 10 and you were at 40, that's a lot of deviation. You're pretty far away from that mean of 10. But maybe if you were at 12 and the mean was 10, not much deviation, just a little bit. 2's not too significant in that situation. So that's just kind of the idea of that when they're talking about deviation. The closer you are to the expected value, the less deviation you're having. The farther you are away, the more deviation. So you can, again, think of deviation kind of a very similar idea to variability. So let's just look at what the table has. The table is getting labeled here. They give us on the far left of that table they have temperature in degrees Fahrenheit. And again, we're at this point on the back of the notes, guys. There's 2 pages here. We're on the back side. And so the temperature is listed from 53 in order all the way down to 70. And they also included the multiple ones. Like there's multiple 60s in that table, multiple 64s, and multiple 68s. So keep that in mind when you're doing this table, guys. Then they show us in the middle, they label it as distance in degrees Fahrenheit from the mean of 63 degrees Fahrenheit. Okay, there's a key word in there, guys. We've talked about this one over and over and over again. The key word in that statement is distance. And what do we know about distance? It's never negative. Distance is never negative. You can never travel a negative distance. You can't go back in time and take a distance away, so you can't lose any bit of distance when you're thinking of actually moving. Now, there's different ways to think of distance where you can see a negative, but it's not real distance when we're getting into that. Just always it's safe to have the assumption that distance is not negative. So, since distance is never negative, you can expect that middle column to have no negative numbers in it. So there you go. It's eliminated some possibilities for an answer already on the middle column. So on the far right, it says deviation from the mean, distance and direction. So remember, deviation is how far you are from the mean. So they want to know first the distance, how far were you from the mean? And then they want to know what direction. Well, you think of it like a number line. You can, if on a number line, you either go left or right. Those are your only 2 options. So on your directions, you're either going to use to the left or to the right. And if we look at the example they already gave us in that table, they gave you the top one. They already filled in and everything. And they said on that the temperature is 53 degrees Fahrenheit. And then in the middle, the distance in degrees Fahrenheit from the mean of 63, they said it's 10. Well, that makes sense because 53 degrees is 10 away from 63, right? And then the only thing they needed you to do on the far right, which they already filled in for you too, is they're simply asking if your temperature is 53 and the average is supposed to be 63, where does 53 lie on a number line in comparison to 63? Well, if you look at 53 and 63 on a number line, 53 is less than 63. And if something's less, remember what we said, left is less. If a number is less, it is to the left of the other number. So 53 is left of 63. How much left? It's 10 to the left. So that's why they said 10 to the left on the far right column for the top row for 53. 53 is 10 to the left of 63 if you were to look at it on a number line. And that's really all you have to do on these guys. So all you would do simply was talk about a couple here is actually we'll just talk about, we can go and talk about the next 2. There's several multiples here. The next one, 57. 57, how does it compare to 63? In other words, what's the distance between 57 and 63? Well, 57 is 6 away from 63 because you have to add 6 to 57 to get 63. So on distance, on the middle column for 57, I would just put 6. Then on the right, you put 6 again and give me a direction. Well, first ask yourself, is 57 bigger or smaller than 63? Well, obviously it's smaller than 63. And again, if it's smaller, it's less, and less is left. So if your number is less, it's going to be left, and in this case, it'll be 6 to the left. So if I'm just kind of looking at what I have so far, there's what I got. 6 and 6 to the left. As long as we're staying less than 63, we will be left. Now, as you've already probably seen out of the corner of the paper, the next 2 are both 60s. And 60, if we're talking about distance from 63, is 3 away. So in that middle column for the next 2, since they're the same number, 60, I'll put 3 because the distance is from 63 if you have 60, is 3. Okay, 60, is it more or less than 63? It's less than 63. So how much less? It's 3 less. If it's 3 less, it's 3 to the left. So I can go ahead and on my table, on the next two, go ahead and put 3, and then I can put 3 to the left. And sorry, I got a little messy on that bottom one, but that's okay. So that's what we got so far on our table. Okay, they're making it kind of easy for us because guess what? The next 5 numbers, all the same number. They're all 64s. Okay, so that's going to save us a lot of work when we're writing this in because we're going to get the same answer over and over again, right? So think about 64. Now we have a new idea here. 64. Is 64 bigger or smaller than 63? Obviously, it's bigger. It's 1 bigger than 63. So on my table, in the middle, for distance from 63, I'm going to put 1s on every one that has a 64. Okay? Now, ask yourself, if 64 is bigger than 63, what direction do you have to go from 63 to get to 64? Well, since 64 is bigger, you're going to have to move to the right to get to 64. How many to the right? 1 to the right, because 63 needs 1 added to it to get to 64. So, since it's bigger, it's going to the right. So if I look at my table here, on the next 5, they are all 64, so they're all 1 away from 63, and they're all 1 to the right. Okay? All right, just a couple numbers left to work with here, guys, so not too bad. Next two are 68. And keeping something in mind here, since this list is going in order, since we've already switched from left to right, we're probably going to stay right the rest of the way through the table because we're just getting bigger from here, right? And as long as you're getting bigger, you're to the right of a number that you're comparing once you've gotten bigger than the number, okay? So 68 is my next one, and it's on the next 2 rows. Well, 68. How does 68 compare to 63? It is 5 bigger than 63. So in the middle column for both 68s, I'm going to put 5. Then, okay, 5 to the left or 5 to the right. Well, 68 is bigger than 63. Therefore, 68 is 5 to the right of 63. So the next two, 5 to the right. Okay. Then on the last one, it's 70. When I look at 70 when I compare it to 63 is 7 away from 63. Well, if it's 7 away from 63, again, in the middle, we can go ahead and put a 7. Then we'll ask ourselves, is 70 bigger or smaller than 63? Well, 70 is obviously bigger than 63. So it's to the right of 63. So when I'm doing this, I can go ahead and finish my table by saying that 70 is 7 to the right of 63. So here's my table. If you need to pause it to help yourself fill in the table, feel free. But that should have every bit of information you need to know to fill this part in. And what we're going to do is we're going to take this and we're going to answer a question right below it. Okay? So with that information in mind, let's read what the bottom part of it says. It says, what is the sum of the distances to the left of the mean? And I'm reading number 5 right here. It's right below the table. So what is the sum of the distances to the left of the mean? And then it asks, what's the sum of the distances to the right of the mean? Okay, so first off, let's think about it. If they want the sum of something, what does sum mean? Well, sum means that you need to add. You're needing to add a set of numbers. So they want the sum of all the distances that are to the left of the mean. Well, I'll look at my table here and keep something in mind. The top one was to the left as well. I have a left, a left, a left, and a left. I got 4 of them right there. So in other words, these 4 numbers, 10, 6, 3, and 3, are all the numbers that deal with being to the left. So I need to take these 4 numbers and add them all together. So if I go ahead and do that, I already did it right here. If I look at my numbers to the left, I added all of them up, 10, 6, 3, and 3. It's kind of did a little bit of shortcutting here. 10 plus 6 is 16. 3 plus 3 is 6. 16 plus 6 is 22. Simple enough. You have a calculator or phone if you need it. If you have it, use it. If not, pretty simple math still. So that answered the first part to the left. Then it says, what is the sum of the distances to the right of the mean? Well, let's think about how mean works. Mean, in a nutshell, is taking a balance of the bigger numbers and the smaller numbers and finding a way to put them in the middle. Kind of find a kind of middle ground. Okay, we're not all the way up here, but we're also not all the way down there. So let's just kind of find a place that we kind of average out to be. So if that's what mean does, and there's 22, there's a total of 22 to the left of it. Sorry if my directions are off here. So there's 22 to the left of it. Then how many do you think will be to the right of it if it's supposed to balance it out? If there's 22 to the left. Well, to me, it would make sense if it balances it out, there should also be 22 to the right. So let's add up all the ones that are to the right and see if we get 22 as well. Okay. So if I look back up at my table here, if I zoom it right in, I have several that are to the right. Now, that being said, just because there's a lot of them, they're just, some of them are just worth 1s. So that might make a difference. And we have a 10 up here for left. So maybe they'll balance out. Let's just see what happens. I got 5 1s. I have a couple of 5s and a 7. So I'm going to go ahead and add them up and see what I get. Well, already saved us a little bit of time here. There's the numbers. I added up all the 1s and got a 5. Both of those 2 5s there gave me a 10. And I didn't do anything with 7 yet. 5 plus 10 is 15. Still haven't used a 7. Waiting till the end for it. 15 plus 7, 22. Well, look at what I got here. Left and the right balanced out. Now, that again, that makes sense, guys, right? Because the mean is kind of a balancing point. So it makes sense that you're probably going to have at least very close to an even amount on both sides of the mean if you're figuring how much is it above it and how much is it below it. So, guys, that's just kind of an introductory step into what we're going to be getting at here. So this is just going to kind of set us up for tomorrow's lesson when we take that jump of now we've seen the balance of how mean works with numbers that are above and below it. And tomorrow we're going to get into actually calculating the mean absolute deviation. But for today, let's just talk about the assignment here. So just to pull it up here real quick, on your assignment should be, again, it'll be on Google Classroom, guys. And there should be at the bottom of it, S.58. So let's just read it real quick, just so we're all on the same page. It says exercise 6 and 7 on it. Now, keep in mind, there's no 7. You're just going to do 6A and 6B. And it says Sabina notices that there is not much variability in a data set. Selena notices that when there is not much variability in a data set, the distances from the mean are small. And when there's a lot of variability in a data set, the data values are spread out and at least some of the distances from the mean are large. Makes sense. She wonders how she can determine the mean to help her develop a formula to measure variability. All right. It says use the data on monthly temperatures for city G given in exercise 4 to answer the following questions. Okay. Well, guys, keep in mind, you need to have your notes for this to help you understand what's going on here. City G had a mean of 63. So you are, once again, guys, comparing the numbers that you put in that table. So use the numbers in your table to help you understand what to put in the table points here. They should match up the same numbers as the middle column of your table. Okay? So all you have to do once you fill in that table, guys, is simply answer the next question. The absolute deviation for a data value is its distance from the mean of the data set. For example, for the first temperature value for city G, 53 degrees, the absolute deviation is 10, because it's 10 away from 63. 53 is. What is the sum of the absolute deviations? So once you fill in the table, guys, all you got to do is take all your deviations and find the sum of them and just write the number down on B. So I think pretty simple, pretty nice, easy way to kind of ease into this. And then tomorrow we'll take another step forward and we will be looking at the mean absolute deviation, how to calculate it, and how to kind of compare it with mean, and just kind of see how it can be useful, how it can help you as far as determining variability, as far as seeing how reliable it can be and seeing how consistent numbers can stay towards the mean. So I think that'll be a good test for us tomorrow, guys. So that'll really be it for today. We'll just talk about that problem for today, and we will move on to the other part tomorrow. So, guys, make sure that you finish the homework assignment for 4/6/2020. Please make sure to get it done and submitted. Please make sure, guys, when you submit it, that you've typed in it and have answers. Still having a few people that are sending me blank documents and maybe just forgetting to check there. Again, I was trying to work out any kinks I can find here, guys. We're trying to work through this. I know for some it's been easier to get the documents to type than others, and we will get those kinks figured out one way or the other, or work out some other way to get this stuff done and turned in here, guys. But please keep persevering through that. See if maybe some of it's just missing detail here or there, but that's keeping you from being able to type on the documents. But one way or the other, guys, keep messaging me until we get this stuff figured out and straightened up. So that being said, that's about all I got, guys. So good luck on your assignment, and please message me with any concerns that you have.